Hi everybody, today we look at a queue, meaning a row of items that are separated by a first in, first out principle and can be retrieved. What functions do we have in the queue that we built exposed to Blueprint? We have two events to delegate that we can bind to an enqueue event, putting things into the queue, and the dqueue event, getting things out of the queue. Then we have an event that is called peek, that just looks what is in the tail of the queue. Yeah, it goes into the head and it's there on the tail. What is there without retrieving it. We can enqueue something, so putting it into the queue. We can pop something, meaning just deleting it without retrieving it from the tail of the queue. We can dequeue something, so we get it from the tail and actually receive it, not deleting it like pop, also deleting it. And we can look if the queue is empty. These are the functions that we want to expose to Blueprint. How would we do it? We start with constructing an object that we created in a C++ class. I come to that later. And the object class is TQueue. That is where we start here. Already have it here. And then we just test a couple of functions. Looking at these bind and unbind events, these are the delegates that we have available and that we can bind to. For example, binding to the enqueue event, just printing it out, or the dqueue event, just printing out the event, so that we are always informed if something happens with my queue. Then I want to enqueue 21 items from 0 to 20, just using a test struct that I created here. I will come to that later, how to create it. And there's just a name and a number within it. And let's have a look how that looks like. So here's the first breakpoint. And now if I continue, there are 21 rows being inserted, and that is exactly the event that is called, so we see what happens. Now I want to peek into the queue, retrieving the one item that is at the tail. That is the number 0, because it was the first one that we put in here. It's a first in, first out thing. So that is what we get with peeking it. Popping, meaning deleting it actually. So we would delete one item, the first out, that is again the one with the 0. And the last step is we dequeue all the items. So while the queue is not empty, we dequeue everything, we retrieve it and print it out. So I would expect from number 1 to number 20, these are the ones that should be retrieved here. And that is what we get. So our queue seems to be working. It's exposed to Blueprint. Now the big question is, how can we actually do that? Let's have a look. First thing, a bit of theory. The queue itself, as I said, is a first in, first out thing. It operates here in a multiple producer, single consumer mode, meaning you have a couple of threads or a couple of different actors that are constantly writing into that queue. And there's one consumer getting it out. So one consumer could be a subsystem, for example, so a singleton that all the time retrieves events from the queue or items, and everything else is just pushing it in. It's thread safe, so that's very important because that will play a big role in the future of Unreal Engine and quite easy to use really. Here's the link for the Pastebin that we will use in a moment. Caveat is, this is not a template. It's really something that you have to implement per data structure that you want to queue. That is also something we will look a bit deeper. And then you have as many flows as you need. Every flow just putting things in, and exactly in the order that you put them in, they will come out and can be processed further. One thing important here, again, is this fact that it's not a template, meaning it's not like the array or the map in Unreal Engine. You really have to create a new queue for each data structure. That is normally a struct, for example. How would we use it? We start here a very new third-person project. Let's start it. I checked here with C++ classes. Normal way would be actually creating the C++ class here. You can do it, but I have a lot of problems doing it. Quite often it's not recognized or whatever. So for me, the easier way is to do it outside of the engine. That is what I prefer. Here, if you look at Visual Studio, you see your project folder. Best practice for me is actually not putting it directly in the project folder, but creating a plugin. But that is kind of the same process, but can be done later. So my plan is now to create a new folder here in the project folder and put my C++ file in. This is my project folder. This is my source folder. In the source folder, I have all my C++ files, and that is where our new class should end up. Let's organize it a bit and create a folder here, for example, containers. So all the different queues that I need per data structure would end here. Let's put it container. Now I have this Pastebin here. You see the URL below. I just copy it here, paste it here, and then save it in that new folder that I just created. So my source, here's my container. And very important is the name. I call it TQueue.h. And that is something you have to remember, because the name plays a big role in the C++ file and needs to be remembered and actually repeated there. So don't make a mistake there. And now we can close that, save it, and have to actually restart and clean up first Visual Studio. What you want to get rid of is the VS, the binaries, derived data cache, intermediate, and saved. And if you have plugins, binaries and intermediate there. All these things you don't need, and you don't need the solution file. What I normally do, I write something like that, a very small command line thing that I just double click and then it deletes it, everything for me. That's the easier way, because you do it quite often, honestly. So yeah, let's delete it now manually. And the moment you recreate the Visual Studio file, there's a lot of compiling going on in the background, and you will see that it recreates a lot of these structures again. And here you can be sure that it really screens all your files and make sure that the Visual Studio project knows each file. And now we should see our new .h file, tq.h. Let's have a look here. The first thing, quite important, as I said, is the name. So it's called tq_generated_h. If you have another name, it needs absolutely to be the same, otherwise you will get problems. What we queue here is this fq test struct, so a mini struct that I just dumped in. There's an older video from me looking how to create a struct with all the bells and whistles. You can use whatever you want here. Important is that you remember that name, because we create this queue here only for this fq test struct, for nothing else. If you need to queue something else, do it. But we would have to change it. If I look at the current project and search for all the fq test struct words, you see there are 6-7 of these where you have to change it later on. And that's important, because the queue is always for exactly one type of data type. I recommend using a struct, because worst case you just change the struct and recompile. You don't have to do anything else. So that's the easier way. So let's look at the class, what it actually does in all these sections. A bit more space here. Okay. First thing, as I said, that is this fq test struct. That is an example. Actually, you can delete that if you use any other struct here. But for the moment it's good. You can also just rewrite it and use other parameters in it. Next thing is my delegate. So on queue changed, I have an event that I want to subscribe to. This here is really from the Unreal Engine documentation. The important thing really, again, multi-producer, single consumer. Yeah, so a lot of threads, a lot of actors, a lot of whatever producers will write into it, and one single consumer can consume and process these data. And that whole thing is thread safe. So meaning we have a extremely powerful structure that we can use here, and we can make sure that we don't have any problems later if we go into multi-threading, and the future classes or the future versions of Unreal Engine will do that quite extensively. Now we have the class here. We have a very small constructor, not doing much really. Then we have 2 delegate variables that we implement. They are all this on queue changed. One is for enqueuing, other is dequeuing. We can reuse the delegate because we have the same signature, just passing a bool really. Then we have the original TQueue from Unreal Engine that we expose here. And here you see the MPSC multi-producer single consumer mode that we select. And then you see the functions that we just saw. All are blueprint callable. That's what we did in the demo, like pop, peek, enqueue, dequeue, and so on and so on. And they all work with this fq test struct. If you have another one, as I said, you absolutely have to change that, otherwise your queue will not work anymore. Yeah, make sure if the struct is not directly in that H class, then you have to include it on the top wherever it is. Wherever you define it, best practice is actually defining it in its own directory, an own H file, not really within this struct. Yeah. within this H file. That's just for demo. So let's run the whole thing. We did not really change much, just copy pasting. And now if we, let's take the third person blueprint that we have in begin play event. First thing, we construct this object that we have, our TQueue. So construct object from class. And the class is our TQueue. And here we have our return value, where we should see all the functions that we just saw. Like enqueuing something, I want to enqueue, of course, my test struct. So I make one. My name is just test and number stays 0. And when we enqueued it, we can, for example, peek it. So have a look at it without removing it. So again, get me my variable. We ask for a peek, and the peek will return it without removing it. And we can break it up again and print out, for example, the name. So let's print string it here. Oops, print string, and be done. So I would expect that I see when I run the whole thing that I see this test being printed out, coming directly from the queue that we initialized that way. So let's run it, and here's my test. So seems to be queue is working. That's the way how to expose this TQueue to your blueprints and use it. It's a very powerful, easy data structure, data container, and I think that's quite important to use the right structure, right container, whatever you do there. I will continue this series. I hope it helps. Thank you very much. Bye.